All right, welcome everybody. Welcome to another episode of Web Development. So we are into the second module, right, in our course. Right, the first module we introduced the course, the material, and focus mostly on HTML, right, the technology that we're going to be using for creating the user interface. Right. I always like to go back to my agenda and make sure we're all on the same page, right, that we're following the course material, right? So as it has introduced at the beginning, right? The course is split into two halves, right? The first half of the semester we are building the user interface or the client in a client server architecture, and the second half of the semester, right, right about halfway through the semester, we're going to start looking at the server side of the client-server architecture, which is the back end of the application, the servers, the database, right, interacting with the operating system and interacting with other third-party APIs and even integrating with artificial intelligence. And so the first module we just completed last week, right? We learned how to create the front end, the React web application, right, built on top of the Next.js framework, right? And we learned about some of the uh, most common skills in HTML, right, to build the user interface. And it's a HTML allows only HTML allows you to do a kind of like a rough layout of the application. Also, very good for prototyping, navigation between various pages. And React allows you to break up large screens into smaller components that you can then put together. But as we saw last week, the output of application only using HTML all by itself, it's not very appealing. So today we're going to introduce CSS, right? This is the topic of our second module, right, where we're going to revisit the pages that we built last week, right? In our prior module, we're going to introduce CSS and some CSS libraries, right? So that we can, make this a little more prettier, or a little more presentable, right? So it looks a little more polished, right? And what we'll learn is that CSS is yet another programming language, right? That allows you to go back and say, hey, this heading over here, I don't want it black on white, but I want it red on blue, right? And you can change how it's justified, the font, right? If you want some blinking lights, right? Or want some borders around it. And it also is going to allow us to do something we couldn't do in the last lecture with HTML all by itself, is that it can allow us to lay out things in a grid, in horizontally. It's going to allow us to override not only the look and feel, but the layout of the web page. Okay. Um, and if you remember in our first lecture, because we were a little bit frustrated that we couldn't lay it out, horizontally, we used tables, right, in our layout pages, right. We used a row and two columns, right, to split up things into sidebars, in a horizontal layout, and that's really a bad practice. So we're going to revisit that, and now that we're going to learn about CSS and grid layout, right, and flex. We'll revisit that. We'll fix that, so that HTML tables are not misused for that purpose. Yeah, so that's going to be the focus for the next couple of weeks, right? First, we're going to learn the basics of CSS. It's a fairly large topic. I mean, you could do an entire career, right, out of CSS, out of making pages look professional and beautiful and presentable, right? Really polished. And so we're only going to cover the absolute minimum that we need, right, to be able to be effective, right? And so that's first we're going to learn the basics of CSS, and then we're going to learn how to use CSS libraries, right, such as Bootstrap or React icons, right, to kind of reuse some of the best practices that other folks, other CSS engineers have developed, right, so that we can readily apply those best practices to our own web pages. Okay, so yeah, so the first lecture for this in this week, where we're gonna discuss the lab exercises that are gonna allow us to practice, and gain those skills. And then next week, right, in the second half of this lecture, we're going to use those skills, right, to revisit the Canvas application, right, that we're building, throughout the semester. Right? Remember, throughout the semester, we're building this one application that is inspired on Canvas, right? So we want to build something that looks like this, right? And so right now it doesn't look anything like this. Ours is, using a really ugly font, and we don't have any, and the default styling is gives a lot to desire. But knowing CSS and some of the libraries, we can revisit this and start actually making our web pages look more like what the actual canvas looks like. Another topic that's of much interest will be making our applications responsive. And what we mean by that is that, right, the layout that you see here, right? We see that there's a four columns, right? We have this sidebar here that we ended up calling the Canvas navigation sidebar, and then you have another column here called the we ended up calling the course navigation, right? That allows you to navigate inside a course. Then we have this big column in the middle, kind of like the main content, that is also a column. And then on the right hand side, we have this kind of like the status sidebar. Okay, and this is all in good on such a large screen that where you can splurge and have lots of columns, right, laid out horizontally. But on smaller screens, we also want to be able to have applications adapt or be responsive to, right? We want them to be responsive to different screen sizes, different devices, so that the same exact application can then be used across multiple screen sizes, right? So for instance, if the screen becomes smaller, right, the application should be smart enough to reconfigure itself and perhaps decide that, hey, this is becoming a smaller screen. Perhaps it's a notebook, right, or maybe a tablet, and then you see the other uh, columns kind of competing for space, with the main content over here starting to become smaller and smaller. Proportionally, it's too small. So it should be able to, right, decide that, hey, perhaps I should sacrifice one of these columns on behalf of the more important portion, right? So for instance, we can perhaps hide this column here on the right, and then give that extra space to the main content in the middle, right? And this could continue, right? It's still usable, right? This is perfectly usable in a perhaps in a reduced screen size, like a notebook, right, or a tablet. But then if it keeps growing smaller and smaller, narrower and narrower, you're gonna have the same question again, right? So should we sacrifice some other columns, right? And in fact, perhaps the sidebars on the left are only for navigational purposes, right? They're not really giving us usable content. So those could be sacrificed, right? And those two can be hidden, right? And then the space that we gain then given to the more important part of the application. So learning how to do this, of hiding and showing, right, and how to configure this, is called responsive design. So that's also a part of the one of the main topics for this module. Okay. All right. So that's the plan for uh, this lecture, or the upcoming lectures. Right. We're learning about CSS, uh, CSS libraries, responsive design, using icons for iconography, and making things look much prettier. Okay. All right. Any questions? All right. Let's talk about CSS. All right. So let's talk about CSS. So CSS is a programming language, stands for Cascading Style Sheets. And what it does is that it allows us to revisit what the HTML does, right? So the HTML, right, what it does is that it defines all these tags, right? The paragraph tags and the heading tags, the lists, tables, and all that, and tells the browser what is the structure, logical structure of the document. Okay, and so what CSS can do, right, is to override the default look and feel. So HTML all by itself, right, uses a default look and feel, right? The default font is Times New Roman. The default size of headings, is 24 pixels, right? And heading 2 are maybe 16 pixels, so smaller. And so for each element, right, it has a style sheet. It has a set of attributes that define what fonts to use, what color scheme, right, what background colors, how justified left to the right. So it has all those already configured, and it has a default configuration. What CSS allows it to do is to override that default configuration, right? It allows it to redefine, right, and for a particular document, for a particular HTML document, it says, hey, the paragraph, I know that the default color for a paragraph is black, so black on white. But you can define and say, hey, that paragraph in this particular HTML document, I want the color to override it so that it's red instead of black, right? And that div over there, right? You can reference the DOM element, right? And you can say, oh, well, I want the foreground color to be green instead of black, right? And so on and so forth. Right? It allows you to override all sorts of attributes. Here, we're only showing that it's overriding the foreground color, right? But there are thousands of properties that you can override. You can override the background color, what font to use, whether it's justified right, left, or right, whether you want a border or not, whether you want rounded corners, right? If you want to lay it out horizontally or vertically. I mean, there's just a huge amount of properties that allow you to configure how is it that you want this to look exactly, okay? It also defines some rules on how is it that this here, the left-hand side here, these statements, right, saying that the div is green or the paragraph is red. These are called CSS statements, right? Each one is a statement, and the statement is made up of two portions. The left side of these statements, right, is what is called the selector, right? Meaning it allows you to select or reference portion of the HTML document. It allows you to say, hey, this particular element or family of elements, right, in the tree, in the DOM data structure, I want these elements to be blue or green or yellow, right? So the selector allows you to define what portion of the document are you talking about, right? And it has a whole bunch of symbols, right, that allow you to do that. You can use the names of the elements, like over here, the names of the elements, p, div, h1, h2. You can also define reference or attributes, right? The elements have attributes like ID and class. So you can also reference these classes and these IDs as part of the selector. For instance, this says, H1 whose ID is intro, or this one says H2 whose class, the dot means class, is method. So it's this one, method. Or this one is the H2 whose class is summary. So the H2 whose class is summary. See that? So the selector allows you to say, hey, specifically these elements, right? I'm talking about those elements. And then the second part, right, of each statement, CSS statement, is the transformations, right? The properties that we want to configure, right? What are the transformations that you want, right? I want to transform the font, the color, the left-hand side, right-hand side, the border, right? And so those are just a whole bunch of attributes and value, name value pairs, name value, name value, name value, of how is it that exactly what you want to do to that. Once you've identified the specific element in the document, what is it that you want to do with it, okay? So that's what CSS is. It's a programming language, right, that allows you to configure the look and feel of a document. Now, these two programming languages, HTML is a programming language, CSS is a programming language, and they're referred to as declarative programming language. They declare, that this particular element is styled as a heading or as a paragraph or as a div. And whereas CSS also declares, right, that those elements should be red, green, or blue. Okay. Now they're declarative language as opposed to functional languages, right? So functional languages is also programming language, but you can create functions that can compute. They have algorithms, right? That you run for loops and if statements that can give you an output based on that algorithm. CSS and HTML are not functional programming language. They are declarative, the functional programming language, right? They declare things. They cannot compute anything, right? Right. So cascading style sheets, CSS, right? They are typically um, implemented as files that have the CSS extension .css, right? Just like JavaScript files are declared in .js files or .ts files or TypeScript files, and those are functional programming uh, algorithms, right? Whereas CSS, right, these rules, okay, these rules over here, they would be declared in .css files. Now you can declare the CSS, the language, the statements of CSS can be declared in three different ways. One, it can be declared right on the element. You can say, hey, this particular paragraph, I want the color to be green, right? Using this style attribute. The style attribute allows you to apply several style property values, right, to that specific paragraph, right? And then it would paint that particular paragraph in a particular color or background or borders and whatnot. Right? This is considered to be a bad practice, right? Even though the language absolutely allows you to do something like this, right? It's nevertheless is a bad engineering practice. The next best place to put this is in a style attribute, a style tag. Now, this is for plain old HTML documents, .html documents. We're not working with HTML documents, so you'll never have this problem. But giving you a little bit of history here, right? That we used to build web pages with plain old .html documents, right? And these HTML documents could declare inside of the HTML documents. You can declare the style right on the element. You can declare it inside of a tag called the style tag, right? In there, that's a little better solution, right? That you can collect all the transformations in one single tag, and then it would be applied to all the elements in that particular document. Right? That's a little better, but still not the best. Now the best solution is to declare your CSS file completely outside of the document, right? And then reference it from within, right? In plain old HTML documents, you would use the link, right? And you would point to the location of this file. And so that's the best. And so we're going to follow this strategy of declaring our style sheets in separate files, right? And then referencing them wherever we need it, right? Now, in our case, we're not using plain old HTML documents, but still, we're going to follow the strategy of having CSS declare in a separate file, and then we're going to load that in and reference it, okay? All right, so let's just practice and take a look at how is that would apply CSS to a document, right? Again, this is a little bit how you would do it in a raw HTML document. Also, this is important so you can distinguish syntax that you would use in an HTML document and syntax that you would use in a TypeScript document, right? It's important, even though you're not going to be applying styles in a raw HTML document. Nevertheless, it's important that you know the differences in the syntax, right? Because you're going to run into an HTML document, right? And you're going to have to open it up, and you see that, hey, this is not exactly how I do my React coding. Why is it different? Okay, so that's why we do need to know where things came from, right? So in raw HTML documents, you would use the style attribute, right, on an element where you can provide a set of name value pairs, right, of CSS properties and their values, you know, uh, delimited by a semicolon, right? So you'd say, I want the background color yellow on this paragraph, and it would paint it, with the background yellow. Or you can combine several properties, maybe the background color blue, but the foreground color to be white, right? So it would be white on blue. And this one is combining the white on red, okay? Again, separated by a semicolon. Notice the property names, right, are all dashed. See that? So the property is, if it's a compound word, it's those two words, all lowercase, right, and separated by a dash, right? So all the property names, the official names of the property, the CSS properties that you can control, right, are all lowercase, right, and they are dashed, separated, right? You separate compound words with a dash. If it's a single word, then it's just that word, lowercase, okay? So that's the standard. That's the CSS standard. All properties are lowercase and a dash, right? And that's important to know, uh, only because we'll see that is not quite the naming convention that we follow when we are coding these properties inside of TypeScript. Okay, it's not quite the naming. Now, if you are in a CSS file, then yes, all the naming convention follows this naming convention, all lowercase with dashes. But when we are in TSX, right, instead of JavaScript files or TypeScript files, right, the naming convention is going to be slightly different. It's going to be no dash, right, and instead the letter of the second or third word, right, it's capitalized, right, meaning we follow camel casing, right? So here it is. So here it is. And the equivalent naming convention in a TypeScript file is to instead, right, remove the dash and instead use the camel case, right? The reason for this is that, just like in CSS, these names are all dashed like this. They have an equivalent JavaScript API, right, that allows you to control all these CSS attributes, but programmatically from JavaScript, right? And these properties, right, in JavaScript are all camel cased, right? It's exactly the same property, but instead of dash and then the letter, it's the capital letter. Make sense? The equivalent one. Okay. So in our world, right, in the TSX world that we're going to be working on, you'll find that all our properties are camel case like this, right? And this is because we are in a JavaScript world, right? And all variable names follow this naming convention, right? They're all camel case. Start with a lowercase, right? And then each compound word is capitalized. Make sense? And these refer um, to standard names, right, in the API, right, so that we can control the CSS, the look and feel programmatically from JavaScript. Okay. Also, the other naming convention that we are noting here is that instead of using the double quotes here, the double quotes, right, in plain old HTML documents, in JavaScript files or TypeScript files, instead we use the uh, double curly bracket, right? And this syntax can be, uh, take you by surprise at first, but once you understand the idea here, it makes more sense. For instance, the inner curly bracket that you see here, the inner curly bracket is defining an object. It says this is an object, right? This is the name of the and objects are made of properties and values, property value, right? And field, and then the value of that field, okay? And then separated by a comma. So for instance, here you have property background blue, color blue, and a comma, and then color colon white. And this inner curly brackets says that this is an object, right? It's formatted for JavaScript, right? Which is called a JSON object, right? It's JavaScript object notation. It's a notation that has become very, very popular, right, for encoding data, right? So yeah, so the inner curly bracket means that this is an object, and these are the properties and the values. The outer curly bracket This just says that, hey, we are in a JavaScript file, and we're saying that we are assigning to the style attribute here, we are assigning an expression. So these outer curly brackets says that what's inside is an expression, not a hard-coded string. Here, right, this quote literally says that this is an actual string, right? I'm passing you a string that you need to parse and make sense out of. Right? Here it says I'm not passing you a string. I'm not passing you a string. So the outer curly bracket says that what's inside is not a hard-coded string, instead is an expression. Now the expression could be a hard-coded object, right? Or it could be a function that gets invoked, right? And then that function is responsible for evaluating into an object, right, with properties and values. So it could be a function that goes out to some database, does some really complex computation. As long as its output is an object, right, with property values, then you're good. That expression is valid. Most commonly, these expression will be, either hard-coded JSON objects, right, or properties that are assigned some variable, right, or a function that computes that value programmatically. Make sense? So if we are in a JavaScript file or TypeScript file, you'll see this notation, double curly bracket, and these are JSON objects. Okay. Now, if you are in a JavaScript file, in a CSS file, we revert back to the dashed syntax. Okay. So like here, right? When you're saying when you are referring to properties or variables that you declare, we use the dash notation. Okay, so for instance, it could be that we find ourselves using this particular style over and over and over, like these elements are always with a foreground color white, the background is blue, it has a so-and-so border, and it has it's dashed, and it has these rounded corners, and the height is whatever, the width is something, and it's positioned in a particular, if we find a particular style that is very useful to us and that we would like to reuse over and over and over, you can create a class. You can create a named class, right? Almost like a named variable, where you can collect all those transformations, right? The background color, foreground color, the font, right? The border, the rounded corners, and it's flashing, and it's justified to the right. So you can collect all those transformations, put them all under a curly bracket here, curly bracket, and then name them, give them a name, right? And notice the dot in front of it. See that, the dot, right? That means I am declaring a class that can collect all sorts of properties and values that I can then apply, right? I can apply them using the class attribute, right? So I can say, hey, paragraph, use the class name, background yellow, that collects all sorts of things. Okay. Now this is in a plain old HTML document, right? And you might find yourself editing an HTML document, right? So don't be surprised, right, that you will find these kinds of styles that you need to actually edit. Now, in our case, right, the instead of having a style attribute, in a TypeScript file, we are way up here in the abstraction layer, right? The HTML document is way down here, very low level, what the browser would read, right? But we're way up here in the abstraction layer. We're never going to use the style attribute to declare classes. Instead, what we'll find ourselves is declaring the styles in a separate file, right? Which is the best practice anyway, right? So in its separate CSS files, we would declare all our classes, all our CSS rules, right? And typically what we would do is that we would import it, right? Or load it up into where we are going to apply those classes, right? Now in a plain HTML document, you would do that using a link, right? And you reference to the file, right? And then those styles can then be applied into your document. In our case, right, we don't have HTML documents, so we can't literally do a link. Instead, the equivalent in our case in a TypeScript file is that we're going to import the file, like style.css, and then we can apply those styles. Okay. And you very much like we would do regularly in an HTML document, right? And that's the intent of React.js. It's trying to be, very, very high level, right? But nevertheless allows you to do everything you would be able to do manually in an HTML document, right? In the low level programming, but implemented in a much nicer, in a way that allows you to, break up content and bring it up together and import it and combine smaller pieces into larger components, right? So that's the intent of React. It tries to keep you, allowing you to do what you normally do, but using a much higher level implementation. So yeah, from our point of view, the way we're going to be doing is this. We're going to declare our styles in separate files like this, right? And then we're going to import those styles, using the keyword import and then the file that we want to, the CSS file we want to import. And then we can just apply those styles like we would. With one caveat, right? Instead of class, like you would in a plain old HTML document, we would use class name instead. Class name instead. And the reason is that uh, since we are in a JavaScript file, the keyword class, right? This keyword class is already reserved, right? In the JavaScript namespace, right? It's reserved for declaring classes, right? In the object-oriented jargon, right? Classes allow you to, declare, structures that can be instantiated into objects and whatnot. So classes have a very specific meaning, a very specific role, right? So that we don't confuse classes, right? The attribute, when we are in the TypeScript world, in the JavaScript world, we use class name instead of class. Make sense? Other than that, right, we can use the classes like we would regularly in an HTML document. Make sense? So yeah, here's where we are, this is where we are, the world that we're going to be living in for the next several weeks. Right? All right. All right, so let's talk about CSS, and we'll start off with some of the simpler things that you can do with CSS, right? Just to get our bearings, right? Just to get accustomed, right, to the syntax, right? So let's get playing around with the most fun part of CSS, just playing around with colors. Okay, so here it is. Here's a code snippets in a TypeScript file, right? That where we are having just a simple paragraph, and we want to control the foreground color of a paragraph, right? So here's a paragraph. Text can be colored and style to be bold, blah blah blah. So okay, so we are applying to the whole paragraph. We are applying the color blue. So there it is. Here's our paragraph, and now it's the foreground color is blue, right? Very simple. And we can combine it with other properties, right? Before it was just the color blue, but now we are combining it with the background color to be yellow, right? So now our paragraph is blue on yellow, right? And so here's an example of applying this in our labs, right? Where we are painting this particular paragraph to be white on blue, right? That, we can import that into our page, right? And verify that indeed it is white on blue. Uh, Now, we did say that it's a bad practice, right, to apply styles right on the document, right? Although that is true in the HTML world, it's not as bad here in the TypeScript world. I mean, if you're hard coding it like this, then yes, it's a bad practice like that, okay? But it's not as bad practice if this were a function or were a variable, right, that can be computed. Then that's not as bad, right? Because you can always configure what the algorithm is, right? And based on that algorithm, this can be evaluated to something else, right? You can configure it presumably, right? But if you hard code it like this, then yes, it's a bad practice. Uh, a better practice is to, instead of declaring this locally and directly on an element, right, you would declare it in a separate file like index.css, right, and then you would import it right inside so that it would apply those styles to that element. Okay. Now this says that all paragraphs are white on blue. And I don't know if that's what we want to do, that all paragraphs, we want them to style them all the same. And more commonly, we want to be able to be a little more specific and say, hey, this particular paragraph, I want this color, this other paragraph, I want to be something else, right? And that's where classes come in. Classes allow you to declare styles, right? And, combination of properties that are useful, give them names, right? That collect all sorts of transformations, and then we can then apply those collections of properties. We can then go ahead and apply them to various parts of the document. So here we presumably we've declared a style that changes the foreground color to be blue, the foreground color to be red, and here the green. It's being applied to this header, then this whole paragraph, and then this smaller span, right? And so these are various colors, right, that we've declared in the CSS. And then when we apply it, we see that you have indeed the heading is blue, the whole paragraph is red, but then a specific text piece is green. Okay. Here's another example of declaring uh, backgrounds, right? Now, notice the naming that I'm following here, okay? For instance, the dot in here, they all begin with dot, and that means that it's a class. It's a class, right? And that's the name of the class. Notice the naming convention, it's all lowercase, dashes, right? And so and then we apply them, and we are applying them to by assigning the value to class name. Okay, so these colors, or these foreground colors of color black, white, whatever, is being applied to the paragraph, the header, right, or the span. All right, but notice the naming convention. It's a class. That's why the dot means that it's going to be applied through a class attribute. But then notice the naming starts with WD. Right? And so WD is it's a token that I've chosen, right? That in my case it means web dev, right? And I'm following the naming convention, for my own purposes, right? That I am prepending all my classes. They're all going to start with WD, right? And the reason is that oftentimes you find yourself combining multiple classes from a whole bunch of different sources, right? Maybe um, from Tailwind, some classes from Bootstrap, right, and some other classes from icons, right? React icons. They all have different classes, and they all have different names, and so and you start combining these names, and you don't really know which ones are yours and which ones are not, right? And so it's a good practice to prepend or give the names to your classes something that you can recognize right away. So I'm using WD. You can choose something else. Typically, you'll find in when you start working for a company or a particular industry, they'll follow their own naming convention. They'll use maybe an abbreviated name. If you're like in Amazon, they'll use AMZ, for instance, right? So all their classes or the naming convention is that they'll prepend AMZ with everything so that they know that these things are by us. We own it. Okay. Then after that, these I'm using FG, as a abbreviation for foreground, color, or FG color. And then in the end, I'm giving the specific name for colors, black, white, blue, red, green, uh, which is fine, right? I'm being very specific about the color name. In some libraries, you'll find that they'll follow a naming convention where they're not very specific about the actual color that is being used, right? For instance, Bootstrap uses a naming convention where instead of specific color names, they'll use generic names such as primary, secondary color, right? Success, alert, right? Information, and so they're not specifically um, specifying any particular name, any particular color, but then obviously they'll map it to some color. This allows them to to have different versions of the library with different themes where it's the same class name but implemented in a different color scheme, right? And so that all your CSS is using these abstract names, primary, danger, success, alert, info, right? And then you can change the theme, and the whole, your whole web application changes from one look and feel to a different look and feel, as long as you follow the names that they provided, right? All the colors will work together, right? They'll all blend with one another, and so it's a great approach, right? As opposed to specifically choosing a specific color hue like I am doing here. So for background color, I'm doing the same thing, right? I'm prepending my names for the classes as WD, right? BG color. Again, this is my naming convention. Whatever industry or company you're going to be working on, the team will decide what those naming conventions are, right? All right, so let's demo these a bit. So for instance, let's in lab 2, let's see where we are. Okay, so these are our labs that we worked on last week. In lab 2, we had this lab to introduce CSS, right? And the code for that was here. There it is. Right. So let's play around, trying to replicate a bit what you are asked to do here. We have, for instance, the declaration of these classes into index.css. So let's create here index.css, and let's declare some of these classes in here. There we go. And some of these classes too. There we go. And then some of the code that uses this. For instance, here we had in page, right? We had the declaration of the background color, blah blah blah. So let's copy that into our page here. There we go. And then we have an example here of how to use the foreground colors. Okay, notice that this is in a separate file, right? So this is a separate component that we can then import, right, and apply to our lab 2. Let's see how this renders so far. There it is. So we have this, let's make this a little smaller. So lab 2 styling the style attribute. So in the foreground colors, right, this is a separate component that we can then import, right? So this is an entire separate component that has this content. So let's create a component here. Let's use the React tools that I've installed here in IDE. So it has a whole bunch of templates that you can bring up. So this is a React functional component that already names it using the name of the file, right, automatically. And then here I'm just going to paste the content that we copied from the example. And then we can import it into our lab foreground color. So I'm going to import it from here. So foreground color, there it is. And it renders like that. There it is. So foreground color, where we are changing the color of the heading. We see what we're doing here, right? In foreground color, we are applying this style to the foreground color, and this is a color blue that is declared in the index, right? In the index of foreground color blue, there it is, right? So that particular foreground, right? It's that blue right there. Okay. And then a couple other examples of the paragraph. We're giving it red, and this particular little piece of content is green. So there it is, green. All right. Same thing with the background color. Right, we're creating a separate component that to play around with the background color. So let's create a functional component called background color, and I'm just going to copy this and then just paste it here like that. And then we're going to import that into our page just to see how it renders. So background color, there we go. Let's see how that renders. There it is, background colors. So background colors with a white on blue. right? And we can see that here, right? In the background colors, we are applying this to this text, background color text, we are applying the, notice, okay, notice that we are applying two classes. See that for the background color here? This background color, we're applying two classes, right? We are applying the background color class, right? Which is this one, background color blue. So this is the background color, right? But we are also applying the foreground color white. See that? So basically the classes is a combination of these two classes, right? It's this blue with this foreground color white. See that? And so it's the arithmetic addition of all the properties of all the classes that are being applied to that one heading, right? And this one is applying two also. It's applying the foreground color black and then the background color to be red. So the paragraph becomes black on red. See that? Right? And then an inner span, right, is declaring this particular piece of text to be foreground color white, right, on a green background, right? And that's how this becomes white on green. Okay, make sense? All right. All right, so go through these exercises, play around with it. Gives you a chance to practice these skills. And the intent is that you get a feel for declaring these styles outside in a separate file. You import them at some top level, and then this gets applied to all the pages that are children of this top level component. Okay. All right. Okay. Let's talk about the box model. So the box model refers to a set of rules that browsers follow, right, when they are calculating, right, the look and feel and the layout of a screen, right, of the entire screen or individual components, right? So let's talk about this, right? So the browser, what it does is tries to compute, right, where all the content is going to be laid out on the screen, right? And for each piece of content, from every pixel to every character, every word, right? Or set of words that are collected inside of some tag, inside of another tag, inside of another tag. Every single element, right, has a box model, right? And what it is that every single content has a rectangular area that tells it where the XY position is, where on the screen it is, what's its distance from the top and the left of the screen, of the edges of the screen, also how wide it is, right, how tall it is, and then that box, you know, based on the XY position and how wide and tall it is, right, inside of that box, right, um, it then breaks up that box into these four areas, right? The innermost area is the actual content, right? And this could be an individual character or could be a word, right? Or collection of words inside of a tag, right? So in the tag, you have its surrounding content, its surrounding content and that content is what we refer to here in blue, right? Now the each collection, each tag, right, defines a bounding box, right, around the content. Okay, so you could draw the actual bounding box, and the content is inside. Now the white space, the pixels between the bounding box and the actual content, right, is referred to as the padding. Right? How much is it padded? If you have the content, if you have the rectangular area around it, if there's any space above, below, right, to the right or to the left, right, we call that the padding. Right? Then if the bounding box if we actually draw the bounding box, right, by default, the bounding box is infinitesimally small, right? The border around your the box, right, is invisible, right? But you can actually draw it, right? And that's called the border, right? You can say, well, I want the border to be 1, 2, 3, 5 pixels wide, right? And I want it to be black, and I want it to be red. I want it to be whatever color it is, or then I can choose any number of styles, right? With dashed or beveled or whatnot, right? So that's the border. And finally, this box, right, has, with relationship to other boxes, it has a spacing of how far it is from other content, other boxes, right? And that spacing, right, between the other boxes is what we call the margin. What are my margins on the right or the left? How far I am from something above me or below me? We call that the margin. Okay, and we can control all these properties, right, of the padding, the border, the margin, the width, the height, the position. We can exactly say where things are, right? So yeah, margin is the spacing between the boxes. The border is what's drawn the bounding box around the content. The padding is the white space between the border and the content inside. You have the width, the height, right, the position, obviously, and the actual content. Okay. Right. Let's talk about block versus inline, right? So the the box model, right? All this position and width and height and padding and margins and all that, plus the uh, two categories of how we want to lay out things on the screen, right? The browser uses these two general ideas, right, of how to lay out stuff on the screen, where to put these boxes. Okay. Now these boxes have two main ways of deciding how they're going to end up, where they're going to end up on the screen, right? These bounding boxes, right? One of them is the inline layout, right? Inline layout is that these boxes, right, are going to be drawn one after another, right, from left to right, right, and starting from the left, and then moving towards the right, and then when it ends up, when there's no more space, right, it's going to wrap, it's going to go down further a little bit, right, and then it's going to continue, right, in the next line, right. So it flows from left to right, right, and then it wraps and then continues. So that's called inline. So some elements like span, input fields, images, right, all those uh, they render from left to right, right, and then they wrap around. The other uh, big category of how to lay out stuff on the screen is blocks. So block elements, right? They don't flow from left to right. Instead, they want to take up the entire width of the screen, right? They want to be as wide as possible, expand to the full extent of whatever it's constraining them, right? Whoever is above them. It might be that I have the entire screen, right? You give me the entire window of the browser or the page, right? And I'll be as wide as that. Now, if I'm inside someone else, maybe inside of a table, inside of a column, right? Then I'll be as wide as the column allows me to be. So block elements tend to be as wide as possible, right? And so what they do is that if they have something on the right hand side, they'll push it off and it'll force that element to wrap into the next line, right? So what they do is that they create these vertical spacing so that blocks are just take up the whole screen and then they just render vertically one after another. Examples of this are headings, right? So a heading, right, takes up the whole screen, right, and then it creates a vertical spacing onto pushes things down, right? Then you have paragraphs are also block elements, right? Again, so inside the paragraph you can have inline, so words, right, that wrap around, but then the paragraphs create this vertical spacing, right, pushing other paragraphs below it, down vertically, right? And then you have divs. Divs are they're generic block elements, right, that are full width and add a division, a vertical division, right? So here's an example of various elements that either behave as block elements or inline elements. So here's the heading. The heading wants to be as wide as possible. The content inside renders inline, right? The block itself takes up the whole width, but inside each word is inline, right? So yes, the heading takes up the whole width, but then each word, right, is flowing from left to right. When it reaches the end, it wraps. So block versus inline. Paragraph, same thing. Paragraph. Notice that this heading, even though there's a paragraph right next to it, the paragraph doesn't render to the right of the heading, right? It's forced to render below it. See that? So it creates a vertical spacing and it pushes it down. That's why the paragraph is rendering underneath. That's why the heading here, the word heading, is not following right after this word elements, right? Otherwise, if paragraph and heading were inline, then the word heading would follow right after elements. See that? But because heading is inline block, it creates the vertical spacing separation. Okay. The same thing with paragraphs. It's also a block element. That means that it's also going to create these full width, right? And then it separates things vertically, right? So that's why here width and normal, the word normal here, it doesn't follow width. Right? That's why normal is in a separate line, right? It does not continue. Now, some elements can be inline, like span. Span, just like div is a generic block element that creates division, span is a generic inline element, right? That uh, if the element already was inline, it's not going to change it to be any more inline. So for instance, here you have span elements, right? And then these render inline, the word render renders right next to the elements. See that? Span elements render inline. See that? So it follows the flow. So it doesn't cause the breakup of the line, right? It doesn't add any vertical spacing, right? So you might say, well, then why even bother with span, right? Why don't you just put render right after elements? What's the point of even adding a span? Well, the reason is that span allows you to logically group together content. Just like heading over here, H1 is allowing you to logically group together these words, right? And giving them some meaning, right? That I want it to be a heading, right, of a particular size. Span allows you to do something similar. Whereas heading will give you a vertical spacing, span doesn't give you vertical spacing. It just allows it to flow, right? But it allows you to, for instance, span allows you to um, grab that particular piece of text, right, and perhaps add, assign some styling. Maybe I want to paint it in a different color. I want to highlight it, right? I want to change the background to be yellow, right, and the foreground to be red, right, just to, highlight that specific set of words, right, but not the others. Yes. I want to separate between the two. So here's a couple examples of applying some styling to different block elements and inline elements. So for instance, here, the H1, we're applying the background to be yellow. Notice that it takes up the whole width to be yellow. Same thing for this paragraph. It's the background is blue, white on blue. So again, it takes up the whole width of the screen. Whereas these span, even though we're highlighting them with white over red, right? They're not separated in different lines, but in the same, just flow from left to right, right? And one could be white on red, the other one could be, yellow on blue or something, right? They could have separate styles, right? A couple other styles that we're introducing, a couple other things that you can do. You can configure other styles. So here, for instance, we're demonstrating styling borders, right? So we have the borders, the background color to be red, right? So this span, I'm applying the red background. The border style, we're styling the borders, the different properties of a border. We can say the style could be solid, it could be dotted, could be dashed, could be bevel. There's a whole bunch of styles we want the border. We can also define the width of the border, how wide you want it in pixels, 2 pixels, 10 pixels, 20 pixels, very thick, right? And then we can define the color of the border. Now, most, whenever you're styling, uh, you know, types of stylings that are logically logically related to one another. For instance, all these border styles and width and color, they are all styling the border, right? So they're all kind of related to another because they're all operating on the border, right? So CSS often what we'll do is that they'll give you two different syntax, right, to be able to control or style a particular part of the screen. So if it's a border, it allows you to separate each property individually like this, or it will give you an alternate syntax where you can combine, right, the values into one single string, right, and then give it a generic border, right? So we say border, and then you can give it the style, the width, and the color all in one single line, right? So you'll find this a lot, right? That CSS allows you to say, oh, I can style the whole thing in one single line, or I can break it up into individual properties, right? And that's a very common uh, um, attribute, right? Property of CSS, right? Here's another example where we are controlling the margin. So here's for the paragraph here, the original paragraph, this paragraph right here had no margin. Well, actually, paragraphs uh, by default, right, when they're defined, because they're paragraph, they already define margins above and below. That's why you'll see that if you have a lot of paragraphs, the paragraphs will have a few pixels in between. There's some white spaces in between. That's why that's the definition of paragraph, right? They add some vertical spacing so you can distinguish one paragraph from the other paragraph, right? Whereas div don't. Div will create the vertical spacing, but you won't immediately see where the break is, right? Because it doesn't add any margins. Okay. So yeah, so notice that this heading which is I think it's a paragraph. This heading and paragraph, yeah, this is a paragraph that notice that there's only a couple margins here, but here we're explicitly adding additional margins, and we're saying I want 10 pixel margin all around, right? So margin all by itself with one value, the default understanding of that, the way the browser parses that and interprets that, is that you want 10 pixels all around, right, this element P, right? So notice now we have this much more spacing in between of 10 pixels around, right? You can be a little more specific. You can provide 10 pixels and space 20 pixels. And the understanding there is that, oh, you mean that the vertical margins is different than the horizontal margin, right? So the first value will be for the vertical margins, and then the second value will be the horizontal margins, right? Or you can be a little more specific and give all four values, right? And so you can specify, now you're specifying the margins above me, to the right, to the bottom, and the right, right? So yeah, there's like three different ways to specify the same thing. You want all of them, you want to, above and below, and then right, left, or each one individually, right? All in a single line. Or even more options of how to do the same exact thing is you can break it up into its own property names, right? So there's margin right, margin left, margin top, margin bottom, right? You can specify them, individually like that, in each line. Now, what's the best practice? Very much like when you're programming, right? Typically, when you're declaring a variable, you're declaring a property, usually we like to be very specific what's happening, and ideally we would say, well, use one variable, one per line, as opposed to mumbling, jumbling everything together in one single really long line, right? So prefer the more verbose syntax, right, where you specifically specify the property and the value. It's a better approach. Okay. Here's another example with padding. Padding, what it does is that, again, it's the spacing around the bounding box, right, and the content inside. And here we're applying it to this paragraph over here. Notice that the paragraph before we add padding is almost flush with the bounding box, but when we add the padding, we're adding, space in between the bounding box and the actual content. So that's, again, you can specify a single value, which specify all around, or you can break it up into left, top, right, bottom. You can be very specific of what you want to apply what padding to. Okay. You can also configure the border color, the width, the style, right? So here's a couple of examples of declaring some fat borders, some thin borders, some dashed borders, some color borders. So for instance, here we have the border style to be dashed, right? The and we're giving these names, right? Like border fat or border thin, right? Where we are, providing the border width of 20, 30, 20, 30. So 20, 20 above, 30 to the right, 20 below, and then 30 to the left, right? So top, right, left. I'm sorry, top, right, bottom, left, right? In that order. So in clockwise, it's defined clockwise. Okay. All right, so let's talk about borders. So there is an exercise in the labs, right, that let you play around with borders. Take a look at that. You can define these classes, border fat, border red, right, and then you can combine them with thin and other colors, blue, right, and so you can declare them there, and just confirm that they render as shown, right. So go through those exercises. They allow you to practice this. So go ahead and do that. Padding, right? Again, there's some lab exercises to, just get a feel for declaring classes, right, in the CSS files, and then applying them and combining multiple classes, apply to the same div. For instance, here, this div, we are applying 1, 2, 3, 4, 5 different classes, right? One of them is declaring the padding at the top, how wide do we want it, the color, right? The style, right? And then the color of the background, and all combining them, you to style this one div. Okay. So anyway, practice that, right? And it should look like this. Okay. Margins, same thing. There's a lab exercises to practice margins. Just confirm that it renders as shown. Nothing is stopping you from creating your own exercises if you want to practice some more, right? Try, maybe draw something on the screen or on paper and say, okay, well, let me see if I can achieve this layout, right? With these margins, with these paddings, with these borders, right? Go ahead and try to challenge yourself, right? To practice some more, okay? Corners, you can also configure the rounded corners, right? And by targeting the properties border, and then the position of which border you're talking about, right? The top left corner, the top right corner, the bottom left, right, or the bottom right, and the radius, right, of how pronounced you want that radius in pixels. Okay. So again, practice that. These are just very short, fun exercises, right, that allow you to gain these core set of skill sets. Okay. All right. Yeah. So we've talked about the box model, and we've talked about configuring a specific box, right? We haven't talked about the position. Where on the screen is it, right? Usually the position is entirely left to the browser. The browser decides, right, based on whether you're a block element or an inline element, right? It'll just compute the position of the elements, right, based on the flow of, as it's parsing the documents, it's creating these and applying, block or inline based on how they're configured. And the intent is that these will never, these will never overlap, right? And fix actually. And so it will automatically compute, right? Automatically compute what the size of the box is, right? Again, based on the content, and the position will always compute it. Again, always avoiding that this content is going to overlap, right? Or something is going to you know, spill over to some content, and also it's avoiding any horizontal scroll bars, right? Vertical scroll bars are fine. You can scroll long documents, right, and they just keep growing vertically, right? But typically you'll try to avoid horizontal scroll bars, right? So let's take a look at how it computes the size, how it computes the position, right? And also we'll take a look at that, how we can override that. If we want to specifically have a specific layout, how can we override it? Okay, so here's a couple of examples, some paragraphs, right? That in general right? They are block elements, right? And in general, they will, by default, take up the entire width of the screen, right? And the elements that are inside might be inline, and they just wrap around, right? When there's no more space, they wrap around. Here's an example, right? We have two paragraphs, the yellow paragraph here and the blue paragraph down here. And we have color coded them, right? We said background yellow, background blue, so that's how they render. So imagine these is the whole width of the screen, right? And they're taking up the entire width. Okay. Now let's start overriding some of these attributes of positioning and size. So let's look at size first. Right. Right now, by default, the size is given by these are block elements. So the width is always going to be the width of the parent, whatever it could be the whole window, or if it's nested inside of another element, it'll be the width of whatever the parent element gives it, whatever width does it give it. So it should not overlap. It is bounded by at least by the size of the screen. Okay. Now so that's horizontally. Vertically, the height by default, right? The height is given by the content, whatever the content is. If there's more content, it'll just keep growing, right? Vertically. Okay. And so if there's more text, right, it'll just expand vertically to fit whatever content it has. So again, horizontally, it is bound by the size of the parent, right, which might be the window. Right? So it will never be bigger than the window, right? But so it wants to expand, right? Whereas vertically, it expands whatever the content is, right? If it's more, then it just grows. Okay? So yeah, so that's the basic um, layout. Notice this the second paragraph also would grow down below it, and so the one above grows, it just pushes down any other paragraphs down below it. Yes. So, but what happens when we start overriding the sizes? What happens? Notice that we can override the width. So here, in the two paragraphs, we've decided to override the width to be 100 pixels each, 100 and 100. So now they're both the same width, right? And because they are shorter or because they're narrower, right? The content didn't fit. You see that? So before the width was enough that two lines was enough for the whole content. So the height of the paragraph was two lines high, right? Whereas here, because they're narrower, we have overwritten the width, but we haven't overwritten the height, right? So it grows freely to fit whatever the content is inside. So both are now they want to be three rows high. Yes. Notice that we've overwritten the horizontal layout, right? Because the horizontal layout block says that my width is always going to be 100%, right? The whole width. But we have overwritten that, okay? But we haven't overwritten the height, not yet anyway. But what about if we override both, right? The height and the width, right? So in the first one, we are taking the height to be 80 pixels, and the second one, we're giving it 30 pixels, right? In the first example, clearly 80 pixels is more than we need to fit the whole content. Okay, notice that the text just wraps until it doesn't need any more space, right? But it has more space than it needs here, right? It has, I don't know, 30 pixels more than it needs. And whereas the bottom one, we have given it less height than it needs, right? And so the content is being cut off. You see that? We did that on purpose, obviously. But this is to say that when you start overwriting the default layout algorithm that the default CSS establishes for the browser, then we could run into issues like this, right? Where we cut off content, things maybe start to overlap, right? And all the work that went into the default styling to avoid right things being cut off and things overlapping and blah blah blah, right? We could be working against the the best practices that the browser is implementing. So we have to be ready to own these errors, right? That we have to make sure that this is the intended effect, right? And that it's not by error or by mistake, right? That we actually intended to do this. In our case here, I am intentionally breaking it, right? Just to make a point. Okay. So yeah, so in the second one, clearly we don't have enough height. Okay. So yeah, so let's play around with various scenarios where we might break the layout, and how is it that we can fix it. Okay, so I am gonna spend some more time in this scenarios, in these exercises, only because I want to point out what would be the challenges, right, when you start overriding these layouts. Okay, so let me create here the dimension component so that we can discuss this together. Right? So let me create a dimensions here. Oop, no, new file. There we go, dimension. And let me create a component, and let me put that in there. There we go. Right. And let me bring that into lab 2. And I'm going to put it at the top so that we can find it very easily. So this is dimensions. There we go. Okay, here are dimensions. So dimensions is just declaring just 3 components or 3 divs, right? That's very simple. Okay, dimensions here is declaring 3 divs, right? We have an outer div here, and then we have a portrait is one div, landscape is another div, and then square is another div. And how are they rendering? They're rendering like like normal divs, right? They are taking up the whole width of the screen of whatever parent they are. Where are they? They are inside a a column inside of a table, right? Where the left column of the table has a sidebar, and the second column on that table, right, is taking up the whole rest of the width of the screen, right? So that's why we see that this is the width of the screen. That it doesn't start over here, because here you have a table column, right? So it cannot expand on that, but it is taking the whole width of the other column on the right hand side. Yes. And if I make it bigger, right, it expands the width. Now the height is entirely determined by the content that is in there. Right now, it only has the words portrait, landscape, and square. So it's only taking up uh, one row of heightness. Okay, all right. Now we do have some classes applied here. Certainly, we're only seeing the effects of the yellow background, the blue background, right? The white foreground, right? Because those are classes that we've defined, right? Now, all the other classes like portrait, landscape, and square, we haven't defined those. We haven't defined those. We have it defined right here, right? So let's start defining these, right? So let's do this first one, okay? And let's do it in the index. We'll put it down here. And there it is. So this is how it renders. Notice that portrait, we have overwritten the height and the width, right, as defined right here. Right, the height is 100 pixels and the width is 75. So basically, it's taller than it's wider. Basically, this is what it says, right? And that it's a good name, portrait. Portrait is taller than it's wide, right? And now let's declare all the other two, landscape and square. We haven't done anything. We haven't declared the styles yet, but let's do that now. Let's do the landscape. Landscape. Right, I'm going to put that in there. So if I save that right here, there it is. So landscape is wider than it's taller. That's right. No, landscape is wider than it's taller. That's very good. And the final one is square. Oops. Oh, ah, happened. Uh, over here, right? There we go. So square. So square is going to have both the width and the height the same value. Okay, there it is. So square, 75 and 75. Everybody okay? All right. Notice that what happened here, right? Where I only overrode the height and width. Notice that this landscape, right? Before I overrode it, notice that before I overrode this, notice that they are still behaving like divs, right? That are block elements that they take up the whole width. They haven't been overwritten. But as I override them and now they're landscape, notice that even though landscape has plenty of space over here to fit in here, see that? Landscape would easily fit next to the portrait, but it's not, right? It's not automatically just coming up here and being and rendering right next to it, because portrait is still behaving like a div in that it's declared as a block element. Even though the width is not taking up the whole width of the screen, right? It still has the behavior of creating the vertical spacing, right? And pushing down all elements below it, right? So notice that, as I increase the height, notice that it keeps pushing down all the elements below it. See that? So same thing with landscape, right? If I or if I increase the height to be 275, right? It just keeps pushing all the elements below it, right? So it's still behaving like a normal block elements, creating the vertical spacing. Everybody good? That's important, right? That the location of the elements is based on other locations of other elements, right? That they all work together, right? To fill up the whole screen. Yes. Okay. So what happens when we start changing these relative positions, right? Again, the position of elements is based on positions of prior elements, of other elements on the screen. Right? Well, what happens if those other elements start moving around? What happens to me? Right? So let's play around that. Let's take a look first at relative position. So we can, so not only can we change the size, the width, and the height, we can also change the position, right? But the position has different ways that can be moved around. One of the most common ways to move things around is a relative, right? Relative to itself. Okay? So that's where the relative position comes in, right? You can configure the type of position that you're going to be working with, right? If it's relative to me, absolute to the screen, if you want an exact position that you want it, right? Once you've determined what type of position, you can then specify, right, the distances, right? How far am I from the left, from the top, right? The X, Y position on the screen, right? So CSS provides 4 attributes or um, properties that allow you to position things on the screen. You have left, right, you can measure from either way, from either side, top and bottom, right? And so those are distances in pixels, right? In EMs and uh, different measurements, right? From top, bottom, or left and right, but they are interpreted based on the position property, whether it's relative, if it's absolute, if it's fixed, if it's static. There's different ways that you can interpret these values. Let's look at the simplest one, the relative position, right? So relative, what it means is that it's relative to myself. So the browser, following whether I'm inline or block or whatever, it's going to compute a position for me on the screen, right? And say, that's where it ended up. This is where I ended up being drawn on the screen, right? The portrait or the landscape. This is where I ended up, right? What a relative does is that it allows me to move relative to the position where I would normally fall, right? So right there where I am, right? I can now, from there, I can move to the right or move to the above or below or to the left or whatnot. So many pixels, based on my normal location, right? So for instance, here's an example of the paragraph that we had before, which was normally, both of them were aligned here right next to each other. But relative allows us to say, hey, relative to where I would normally be, I want to move from the left, I want to move 20 pixels, measure from my left, I want to push off, And that what that does effectively, it moves me to the right, right? So if I push off from the left 20 pixels, I'm basically moving myself to the right. So there it is. So here's the paragraph, which would normally fall here, right? You know, both of them flush with one another, right? It's moved 20 pixels to the right. See that? Here's another example where not only are we moving the left, but we're also moving the top. This is kind of like the X, Y, where top is Y and left is X, okay? And we can go both ways, positive or negative. And so here we're saying top minus 30. It's like saying Y, you know, vertical minus 30, right? So where I would normally be, I would normally be right here, right? Because I have some margins. The above paragraph pushed me down, right? So I would fall under the above paragraph. But if I wanted, I can move myself 30 pixels up, right? And I can do it both ways. I could say top minus 30. So I'm, you know, where my top was, I want to be negative to that. So that moves me up, right? Or I can do it, I can push down from the bottom too. I could say bottom 30, right? And that would push me up too, right? So yeah, you have two ways of doing that. And we'll see in a minute, why would you have two ways of doing the same thing? It's very, very interesting. Yeah, here it is. Here's the example where I can give you both the left and the right, right, at the same time. And that means that, for instance, I can um, you know, move my left and stretch it and say, okay, well, fixed it to the left hand side 0, or right, you know, stretch it so that there's 0 pixels from the right hand side to my edge, right? And that allows me to stretch and position exactly right where my left and my right falls together, right? And I can basically, I'm stretching the edges and positioning wherever I want it, you know, a distance from the edges of the screen or the edges of my parent. Okay. Um, so yeah, so let's play around with a couple of these examples. Just again, this is very important, right, to understand how things are positioned. That's why I'm spending a little more time talking about these particular exercises, not so much about the other exercises, but this is worth spending some additional time. So let's create here a positions where we can play around with positions. So let me create here an RFC. Okay. And let's bring the dimension here. And let's bring up in the lab 2, let's bring positions. I'm going to put it at the top so we can follow along. Yeah, positions. Positions. There we go. There it is, positions. So first, let's look at relative. Right? Now, the example of the positions, notice that it's using the same exact 3 divs, right, that we used before. So the exact same 3 divs, but we're going to add a couple other things, right? First of all, we are wrapping it with a parent div. See that? So this parent div is a gray parent, right? And there it is. So this is the parent div. So it's behaving like a normal div. It's taking up the whole width of the screen, right? And its height is given by the overall height of all the children inside, right? And inside we have, you know, one of them wants to be a portrait, this one wants to be landscape, and this one wants to be just a square, right? And the summation of all the heights now affects the height of the parent, right? But the width is want to be as wide as I can. So that's just a normal div being block, right? Now let's start moving things around, right? Notice that I've added here inside the portrait, right? In the portrait, I've added another div inside that where you have the text portrait. See this div, right? And I am adding a class called positive relative nudge down and right, right? So, okay, so the class doesn't exist yet, right? We're going to add it in a minute. But without the class existing, the div just falls where it normally wants to be. And it's at the, you know, it's going to take up the whole width of its parent. So that's the width, right? Actually, we can give it a color so you could see it, right? You can say a WD background color gray, so you could see the color gray. See that? It's, well, actually, no. Let's change it to say red. There it is. Notice that it's taking up the whole width of the parent, like a block element would, and the height is given by the text that's inside. That's the height. Okay. All right. So let's apply now this class that doesn't exist yet. You know, WD. The positive nudge down and right. So presumably the class that I'm going to apply is going to nudge just a little bit down and to the right. Okay. So let's apply that. I have the class right here, and right here, this one, nudge down and right. So let's do that. So, and I'm going to put it in the CSS. Where it is. So notice what's going to happen to this portrait. Okay, so I'm going to paste this in here. So notice what it's doing. It says that the position of this particular div, I'm going to change it to relative. And then I'm going to, from the top, I'm going to move down 20 pixels. And from the left, I'm going to move right 20 pixels. So it's going to go down a little bit and right a little bit, right? Like the name says, you know, that's the name that I chose, right? So I'm going to save this, and now it's going to be applied, right? Let's see, save. There it is. See that? It moved down 20 and over 20 pixels, okay? And notice that the width didn't change, okay? The width was given to me by when it was calculated as being a child of my parent div, which the height was, I think it's what, 75 pixels? So my pixels of my width is still being determined by my parent. Parent is 75, I'm 75. Okay, I want to be as wide as my parent. So that doesn't change. My height is also hasn't changed. It's still based on the content, the single line in there, portrait, that hasn't changed, right? So my size hasn't changed. Only my position has changed, right? Relative to where I would normally be 20 pixels down and to the right. Make sense? Okay. Let's do the same thing with landscape. So landscape is what we're doing with landscape. So landscape, notice we have just a single div here. We have the whole thing is blue, right? We have background blue, foreground white, and it's landscape, meaning it's wider than it's taller. But then we're going to nudge up and right, meaning what we're going to do is that we're going to change its position to relative. We're going to do maybe, I don't know, bottom. We're going to go 20 pixels up, and then to the right, we're going to go left 20, right? So we're going to move us right. Something like that. Let's see. Yeah, there it is, right? Oh, 30. We're going to do 30. So we're going to nudge up and right. So let's see right here. Let's put it in our CSS, and so we're going to apply that. Okay, I'm going to save it. So this whole div is going to move up because it's from the bottom, I'm measuring 30 pixels, up 30 pixels, and then to the, I'm going to move right because it's left 30 pixels. So I'm going to save that. There it is, right? So now I've moved up 30 and to the right 30. But notice that it's causing me to overlap my portrait, right? Something that the browser was trying to avoid at all costs, right? So I'm kind of like working against what the browser wants me to do, and that's fine. I mean, I'm deliberately doing this to make a point, that we could break things, right? And that it's we have to own that, right? And we have to make sure, hey, did I mean to do that? If this is a drawing program where you can drag things around and blah blah, right? And where legitimately things might overlap, and that's fine. If you are deliberately doing this on purpose, right? But just make sure that it's because it was by design and not because you was unintended. Okay. So one point that I want to make here is that notice that the square, even though we move the landscape up, right? Notice that the square didn't move. Okay. It's still its top position is still being calculated. It was calculated before, right? It was wherever the landscape ended up, and that caused it to compute its top position. It hasn't moved, right? The original calculation position is the same, right? The only thing that's changing is the landscape relative position, but that's afterwards. After having computed the positions of all the other elements, then I'm just going to move the landscape up and up and to the right. Okay. And then finally, okay, so we're not changing the square, right? We're not changing the square. Yeah, we're not changing the square. Also, just to point out, the height of the parent hasn't changed, right? Because the overall computation of the height was done before we started moving things around, right? And that hasn't changed. All right, let's talk about absolute position. I want to contrast this other strategy of moving things around on the screen. How is it different from relative, right? It's very important to be able to distinguish between the two, right? And how they are, how they affect the rest of the screen, right? So let's talk about absolute positioning. So absolute positioning, unlike what the name suggests, is not really very absolute. Um, when you first hear the word absolute position, it sounds like there is an absolute immovable position, maybe some kind of X, Y, 0, 0, and then everything is measured from there. And in that sense, it's true. The problem is that that 0, 0 can move around. Okay, you can move around the 0, 0, and then it's absolute from that 0, 0. So in a sense, it's actually relative to the 0, 0, right, that can move around. Okay, so I don't know that if the name is encapsulates really what's going on here. Uh, Now, it is true that if you don't specify what the 0, 0 is, by default, the 0, 0 is the top left corner of the window, right? Of the body of the document. Okay. And so in that sense, yes, it's absolute to that 0, 0. But if you move it around, and you can move it around, then it's relative to the new position of 0, 0. Okay. So let's first start moving things around. Let's see. Yeah, so here it is. For instance, we move the bottom you know paragraph, and we moved it absolute, so that it would show on top of this other paragraph. So let's look at another exercise here. So let's copy this and let's paste it in here into position, and I'll put it at the top here. Position relative, CSS position relative. Wait, do we? This landscape, portrait, blah, blah, relative. Oh, okay, so this is relative. All right, I want to do position absolute. Where do I want to put this? I guess I should create an outer div like that, and then put this up here. There we go, like that, something like that. And so let's see how this renders. Okay, there's absolute position. Absolute position, and I guess one of the things that I did want to point out is I do want to wrap this inside the gray. I want to show you, yeah, gray, exactly. I want to, so let me put it, break, blah, 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 div. Okay, right here. Let me close this. There we go. Okay, there's a gray or a background around it. Okay. Yeah. So yeah, we haven't yet style positioning, right? So there's a gray right there, right? There's the example of, okay, there's position relative. Did we create this class? I don't think we did we? Okay, we didn't. Okay, that's good. That's good. Yeah, we haven't declared it yet, and because I want to show you what happens when you start making things absolute, right? So for instance, here we have this portrait, and we want to say here it is, right? It's portrait, is the background is yellow, and then we have this class position absolute 1010, right? So we're going to set its absolute position top 10 and then left 10, right? So it's like x y is equal to 1010, right? So let's do that. Oops. Let's do that and see what happens. Let's make this a little narrower. Okay, like that. Okay, so let's declare this class. Declare the class and see what happens. Okay, there's that absolute 1010. So let's apply it in the CSS. So notice what happens when I apply that. Notice what happens to portrait, okay? Well, not only portrait, look what happens to the whole screen. So I'm going to save that. Okay, notice what happens. So a few things. Portrait moved up here to this corner, and indeed, it's actually behaving the way we would expect, right? From this corner, this top level corner, which is 0, 0, it's 10 to the left. Yeah, it's 10 pixels to the left and 10 pixels from the top, right? Which is what we decided here. See that? Notice that the position is not relative, its position is absolute. And this is what you would expect. Yes, this is exactly what I would expect. It's from this top 0, 0 corner on the top left corner. Yes? We'll come back to it in a minute. Notice what happened to landscape and square in the gray area, okay? Notice what it used to be. Let me comment that out. Notice what happened, right? It was first the gray area, right, was a particular height. Now, and also the bottom, the landscape and the square were being pushed down by portrait. But when I apply this absolute 1010, notice that what happens is that it's kind of, I have removed portrait, right, from the computation of the location of my other two elements below me. See that? That's exactly what happens, right? When you use absolute on an element, right, it removes it from the calculation of how it affects all the other elements. Right? So it no longer participates in the positioning of the elements below it. See that? Right? It's no longer behaving like a block element. Right? It no longer pushes, right, its space below it. Right? It also doesn't is not contributing to the height of the parent. See that? The parent is no longer as tall as it used to be, right? It's because I've removed portrait. Its height is no longer being added up for the whole height of the parent. Okay, so that's very important. Now the even though this makes sense that there's an XY absolute position 0, 0, oftentimes that's not exactly what we want. More typically, what we want is that the 0, 0 would have been this corner right here. See that? That might have been actually more convenient for us instead of this 0, 0 being tied to the window. It would be very convenient for us to move that 0, 0 to somewhere that might be more relative to what the work that we're doing, right? So that we don't have to compute the position of this and that and do all the calculation if we want to put it relative to this, right? So that where the relative comes back in, right? We can say that this x, that's 0, 0, we can move it around. And the way we move it around is by encapsulating the element inside of another div, like this gray one, and making that parent, making it the position relative, right? And now we will have moved the 0, 0 to the innermost element or the closest elements to be relative. So now the portrait, the way it would work is that the portrait here would move up the hierarchy looking for the nearest element that has a relative position, right? And then that would be the 0, 0, the new 0, 0. And that's why we have here a WD position relative. That's going to be our new 0, 0, right? So all these divs inside, portrait and landscape and div and square, blah, 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 all these are going to be measured against this div over here, right? This div is not doing anything yet because we haven't declared this class yet, but we're going to declare it and we're going to make its position relative. And so now all the absolute are going to be measured from the parent 0, 0 up here, okay? So let's do it. So we're going to do WD position relative, and do we declare it here somewhere? I guess we haven't, so let's declare it here in CSS. We say position relative. There we go, position relative. So I'm gonna, before I save it, notice what happens. If I save, boom, see that? Now the position of portrait is 10, 10 from the new 0, 0, which is this corner over here, okay? All right. All right, so let's do the same thing with the other one, landscape and square. Let's move them around. Let's move them around. Let's see. Let's move around the apply this one to all these. this one's for the landscape, I believe, and this one's for the square. So let's copy those two. If you notice, I'm gonna paste this in there. Oh, I'll paste that in there. I'm not gonna save it just yet, but I'm just gonna show you that here's our landscape has an absolute 50-50. So from this corner, 0, 0 is gonna move the landscape, right? The landscape is gonna move down 50 and right 50, and the square is gonna move 120 to the right, and then 20 down. Right? So I'm gonna save this now, save, and there it is. Now his landscape moved over 50 and down 50 from this corner 0, 0, and square moved over 120 to the right, and then 20 down. Okay. So yeah, and notice that they're overlapping each other, right? We have a portrait, and then on top of that is landscape, and on top of that is square. The order in which they are rendered, right? That landscape ends up on top of portrait, and square lands on top of landscape, is because of the order in which they are declared, right? So first we render portrait, then we land the landscape. That's why it's rendered on top of portrait, and then finally we render square, and that's why it ends up on top of landscape. Yeah. Also notice, because now they're all absolute, none of them are pushing each other, vertically down. And because now they're all absolute, none of them are contributing to the height of their parent. See the gray over here? It disappeared. We no longer can see it, right? Now there are the height of the gray area is 0, right? Because none of its children are contributing to the height of the parent. Okay? All right. All right, let's take a short break, and we come back. We'll wrap up in the discussion of positioning and laying out things horizontally in the landscape and whatnot. All right, I'll be right back. Don't go anywhere. Right, so we took a look at a couple of position options, right? We looked at the relative position, and the absolute position. Now there's a couple more options. There's a fixed position, and this is useful for implementing elements that don't move with the screen. So for instance, just like I'm scrolling here, and the content is changing on the right. Notice that there are certain things here on the screen that are not moving, right? For instance, this top level header. You see this here, this rectangle, it's not moving, right? The content is being scrolled, but those elements are not. Same thing with, if I'm looking at the word processor, same thing. We have a scroll bar, the content is scrolling, but this header at the top is not moving, right? It's fixed at the top level, unlike absolute, right? Absolute will be absolute from a point, right? That might be relative, right? Like the sample here, like for instance, these portrait this portrait, landscape, and square are absolute to this position here on the 0, 0 that we can't see now, because we had the gray parent, and we no longer can see it because the height is 0, right? So even though they are absolute to this, they're not absolute to the overall screen, right? If the screen scrolls, right, the whole portrait, landscape, and square scroll with the content up and down, right? But there is a fixed position. Fixed position is for what the name suggests, is that we want to fix the position with the overall window, and be oblivious to the scrolling of the content, right? So for instance, we have here an example where we can position here a square, right, that is not going to move with the scrolling, and so go through that exercise, and verify that indeed the element is not moving. I'm not going to go over it and recreate it here, since it's fairly straightforward to understand, right, that it doesn't move, but it ignores any scrolling. Okay. All right, let's talk about the z-index now. So z-index, as we saw, in our previous example, things are rendered in the order in which they are parsed in the document. So for instance, this square, landscape, and portrait, the reason one is render on top of the other, where square is rendered on top of landscape and landscape is rendered on top of portrait. The reason is that that's how the browser parses them, right? It parses first this yellow portrait and it renders it on the screen, and then it goes on to the next one and reads the blue landscape, and then it renders the landscape. So that's why it's rendered on top of the portrait. So if they're overlapping, right, you would have certainly a clipping of anything that is below it. And then finally, the square is parsed after the landscape, and that's why it's clipping the landscape, right? But you can override that. But that's the default uh, rendering the positioning between them, one on top of the other, is determined by the document order, right? The order in which they appear in the document as it's parsed. But you can override that by setting its z-index to something different, right? You can say that the z-index is some other value, right? By default, they'll have the same index to start off, right? Z-index 0, right? And but then you can make some elements to have a higher index. Once you have the same index across the same other different elements, then the document order is what it's used, right? If two elements have the same z-index, then the order in which they're declared is what determines whether something is on top of the other, right? But if something is on top of something, right, but the thing that is below, right, that would normally be clipped by something that is on top of it, you can change that. Right now it's below it because they have the same z-index between the two. So the document order wins. But I can make the z-index higher in the one that is below, so that it would win over the elements that would otherwise be on top of it, right? So I can change the order in which they are rendered. Okay. So in this exercise, right, I'm overriding the landscape, right, and giving it a z-index bring to front, which basically is I'm setting the z-index to be higher than all the other z-indexes of both the portrait and the square, right? Well, the portrait doesn't matter, right, because a landscape anyway is gonna render on top of portrait because of the document order, but the square, right, initially they had the same index. That's why square was being rendered on top of landscape. But now because landscape has a higher z-index, it renders on top of square. Okay. All right. All right. Let's talk about grid layout. Okay. So as you know, in prior lab exercises, in the prior implementation in Canvas, that we were defining rows, we were defining columns using table, right? I mentioned that that's a bad practice, right? To use or misuse tables for layout, right? And so, but we still want to be able to lay out things in a grid, right? Almost like if there were a table. Right? So for instance, here are some examples of content that we would want to lay out. Maybe we want to lay it out, side by side, maybe like 50-50, right? Maybe two columns, two large columns, and some of the content is on the left, some content is on the right. Or another very common way to lay out things is to have like you know, a um, a sidebar, or maybe a wide sidebar on the left, like taking up a third of the screen, and then the main content on the right hand side, that takes up maybe twice as big. It could be 2/3 of the screen. Or another very common way of laying out things would be to have a center main content that takes up most of the width of the screen, and then two sidebars, one on either side, one maybe for navigation, main navigation on the left side, some secondary navigation on the right hand side. And there's any number of ways of laying this out. And it would be very convenient, right, that this would be would follow more or less the same kind of structure that we that of a table, right, where you have rows and columns, and you can maybe define the relative sizes of columns between them, right? but without actually using the table, because the tables are meant for tabular data, right? Each row is meant to be a record, right? Each column is supposed to be a property or field in the record, right? Where each field has the same data type, right? Maybe one column is dates, another column is temperature, another column is distance, or whatever, right? But they're not meant for laying out. And so we have been misusing the tables for laying out. That's a no-no. We shouldn't be doing that. So we're going to learn to instead, see what alternatives do we have, right, for laying out things on the screen. So here's an example of two paragraphs, and by default, right, they render one on top of the other, right, in vertical fashion, just like a normal block elements, right? They take up the whole width of the screen, right? And then they add vertical spacing, okay? So that's the default layout, okay? But what if we start overriding this layout, right? So one of the ways to simply override and start laying out things horizontally is to use the float property, right? So the float property allows you to grab content and just push it off to the side, right? Either to the left side or to the right-hand side. This was initially being used for images, right? For laying out images where you would have, long pieces of text, and then you might have an image here, an image there, right? And so on. Now, the default layout of images is that images flow with the text, right? So if you have text, and paragraph, paragraph, image, paragraph, 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 image, normally, what HTML does by default is to just have, just text, and then the image just flows with the text, and then text, more text, and then, intermixed with the text, you would have this image. And so CSS introduced this property of floating, okay, where the image would instead of flowing with the text, right, it would somehow be stuck all the way to the right hand side or all the way to the right hand side, and then the text would just flow around the image, right? So it's a pretty cool layout, right? It's very common in books and in articles, right, where you have lots of text and then you have intermixed images here and there, an image here on the right, maybe then another image here on the left, and so on, right? And then they alternate right and left. One of them is floating right, one of floating left. So that's where it comes from. And somebody said, "Oh, that's pretty cool." Well, but what if we use that strategy, but not just for images, right? We use it for any other content, or not just images. Maybe how about a paragraph, right? So what they started playing around is as well. What if two paragraphs I make them, the width I make them 50-50. Now they would be there would be the same paragraph, but now half the size, yes, but there would still be block elements, right? That would still create a vertical spacing. They would not naturally just flow from left to right, right? They would still be top and top, up and down, right, vertically. So that's where floating comes in, right? So if you apply float left to all the paragraphs, what you'll see is that they start stacking up, right, one after another, as several columns, in one big row, right? And so folks, ran with this idea and says, oh, I can recreate the behavior of tables, right, where you have a row of multiple columns, combining the widths, right, and combining the floating properties, right, to achieve the same kind of layout that a table would give me, right? And so, for instance, here's another example where each of the paragraphs is 33%, right? So each one is a third, a third, and a third, right? That together make up 100% of the width of the screen, right? So you can create cool layouts, right, with this idea. So here's an example of an exercise, that I'm going to show you here, right, where you have the same yellow, blue, and red that we've had all along, right, plus an image down below, right, where we're going to apply the same kind of layouts that we had before. They're all portrait, right? They're all taller than they're wide. Some of them are yellow, blue, red. Okay, and I'm going to float them all left, right? And when you float them all left, what you'll see is that they all start stacking up, right, from left to right, almost like if they were columns, right? Now, obviously, the height and the width is already set, right? Because they are portrait, right? They are 75 wide, 100 pixels high, so just they would just stack up, and they would start behaving like inline elements as opposed to block elements. Okay, so we are now using divs as if they were inline, right? They're just flowing from left to right, right, all the way to the end, and then when there's not enough space, they just wrap, onto the next line, right? And so this allows you to now choose whether you want divs that behave by default as block, or you can override them so that they behave like inline. So you can have columns, right, in one single row of a whole bunch of articles, right? So yeah, so let's try and recreate some of the layout that we had before. Here, for instance, we have uh, adding, half and half, where 50% of each, right? So we have a kind of like a left right layout of left half and right half, both of them 50%, and then stacked up using the flow left. There it is. So 50%, and then adding float left. Now, one caveat to take into consideration is that once you configure elements, right, to float left, the original idea was that you float an image. Once you float it, the rest of the content was just going to flow around the image, right? So the behavior of floating continued with all the text beyond where it was being applied, right? So if you applied it to an image, right, the text kept flowing around that same image, even much later, yeah, even after text that was below the image. So this effect of floating, right, where things just floated around other content, kind of spilled over, to later content down below. So sometimes you would get weird effects where form elements would start now floating floating around each other. So there had to be a way that you kind of like stopped the floating behavior, and that's where the clear comes in, right? You can also configure areas where the floating starts and then it stops, and then it starts again, and then it stops. So where you can create a context that I want you to do the floating here, but then stop. Very much like a table. A table, declares a row, right, where the columns float from left to right, and then they stop, right? And then you might have outside of the table, you don't want the table format anymore, right? So they are very well defined by the parent table tag, right? So same thing here. The way we do that to stop that, we use the clear both, to stop the floating behavior. So here's another example of using, a third on the left side and 2/3 on the right, right? Where you have a 33% on the left and then 67%, to add up 100, and then both floated left. Here's another example of having the main content in the center, right, where you have most of the area of the content, and then on two sidebars on the left and the right, right? So for instance, you can have 20% on the left, 60% in the middle, and then another 20% on the right, all floated, stacked up in one single row. Okay, and then when you combine all three, you have your grid layout. All right. So we're going to be using these kinds of grid layouts throughout the semester, right, to lay out things horizontally, without using or misusing tables. Now, let's talk about flex. So the strategy of using float, like we just saw earlier, to achieve this, stack that extends, that lays out content horizontally, that's kind of like a hack, right? It's using kind of like a side effect of something that was designed for one thing, but then using it to implement something that was missing, right? The horizontal layout. Well, flex is a set of classes or a set of attributes that are specifically designed, right, to have full control over the layout of things, horizontally, vertically, where you can very easily override the default behavior that things might render vertically, and then just switch it around and flip it so that they instead render horizontally. But so Flex is a huge topic. We're only just going to skim the surface, just enough for our purposes, right? That we just want to be able to lay out, create um, this grid layouts, right? That these rows that have several columns, right? And be able to have these sidebars. I mean, that's the whole point that we're even looking at this, right? So instead of using float, right, which would be a particular an alternative, a much better alternative is to instead use flex, right? So here's a couple of examples to illustrate how flex works. So here we have a simple HTML snippet, right? That we have a parent div, and then inside we have three divs, right? And the divs have some content in there of box one, then here box two, and then a new line box two again, and then this one has three box threes, a break, three box threes, a break, and three box three, right? And by default they render something like this, right? The Now I deliberately chose box one to have just one line, right? And only have be so wide, right? Box one is, whereas box two is twice as wide and twice as tall, and same thing, box three is three times as wide and three times as tall. Right? I deliberately did that, to show you how the content also affects the layout of the content, right? Of how wide the content is or how tall the content is, right? So we know that by default these are divs, right? They extend their width to be the 100% of their parent width, right? So these three are behaving like just regular block elements, right? They're being as wide as they can, right? And their height is given entirely by the internal content. Yes, right? Now I've added some styling here only to exaggerate some of the layout. So for instance, the container, I've made it black. It's solid, right? And very thick lines. So you can see that right here, right here. Then they're all boxes, right? All these divs are boxes. So flex box, flex box, flex box, right? There it is, flex box. And they are providing padding and margin, right? So they are providing margins, which is space around the box, right? And padding is space inside, right? Inside the box. Also, I've provided, they'll add some border, a gray border all around, 5 pixels, solid gray, okay? So nothing new here, right? These are all styles that we've seen before. We're all very familiar. Nothing new at all here, right? And then these three, like it's just adding some color scheme so that we can just follow along what happens to these three boxes as we add flex styling. Okay, box one is yellow, this one's blue, two is blue, and three is red. Okay, nothing new here, right? These are all classes that we know, that styling that we've seen so far. Let's now play around with some new styling, right? That is introduced by the Flex library, right? Okay, so first of all, here it is, container. The container is the one of outside, this black, right, border all around. And inside you have the three divs that are rendering like regular block elements, right? Vertically spaced, right? They're all adding vertical spacing, they're all extending as wide, right? And the height is by the content. Yes? Well, let's look at Flex container. We're gonna play around with this, right? It says 5 black and solid. Just by adding display flex, notice what happens to the content, right? The content it used to render from top to bottom, right, vertically, and just by changing display to flex, right, it changes to render horizontally instead of vertically. See that? It flips the behavior of the height and width of the elements, plus it changes them from block to inline, right? So for instance, the width, before the width was determined to be 100% of the parent, right? Instead here, the height is 100% of the parent. See that? Notice that the height of the parent is whatever that is, and they all want to be as high as the parent is high, all right? The height, okay? Now, before, the width wanted to be 100%, right? And the height was determined by the content. Here's the inverse, right? The width is determined by the content, right? This one has only one box one, this has two, this has three. So each one is wider than the other based on the internal content. See that? So the behavior of height and width is kind of inverted, right? And the next thing is that you know, unlike block elements that they add vertical spacing, these don't, right? Instead, these just flow from left to right, right? Just where one ends, the other begins. Right? Before, the divs pushed each other down vertically, these push each other horizontally. You see that? So display flex changes this from, you know, a column into a row. Everybody good? Okay. All right, so let's play around a little bit further just to see what knobs do we have to fine tune this behavior. Okay, so first of all, justification, you know, how to justify content, right? So there are two ways to justify content. You can justify content horizontally, you can justify it vertically. More likely, most of what you're going to be interested is justifying content horizontally. So there are a lot of options here, right? So the way you justify content horizontally is done by the property, by, you know, applying to the container. After applying display flex, you can display the justify content, right? Justifying content allows you to just give values such as, you know, center, spread out, you know, in between. There's a whole bunch of options. Let's look at a couple of them, right? So the by default they are all justified left, right? Or start, right? We'll come back to that in a minute. At the beginning, right, of the left-hand side, right? But you can override it to be in the center. So basically, the three that, you know, are pushing each other towards the right, right? They're now centered, right? That means that the left and the right white spacing is now the same, right? So whatever extra spacing there was is divided equally on the left and the right. So it's centered, all right? The next one is at the end, right? So I told you before, the default is at the start, right? But you can override that and it becomes at the end. So it's almost like justified to the right, right? Notice that we don't use the word left and right. Instead, we use start and end, right? And the reason is that the start and end are terms that are more generic, right? And can be interpreted differently depending on your culture. Okay, like for instance here from our Western culture, you know, we tend to read from left to right, right? You know, if you come from a Latin or Greek, you know, Western civilization, typically we read and write from left to right and from top to bottom, right? But in other cultures, right, and Hebrew or Japanese or Asian or Middle Eastern, they might read, you know, from right to left or from top to bottom or from whatever, some other format of how they format their content. Yes. So instead of using instead of using right and left, you know, for us, start, you know, conceptually is the left side. You start from the left towards the right, right? But that's culturally, right? That's a cultural construct. In another culture, the start might be the right-hand side, right? You would read from right to left as opposed from left to right. So that's why we you know, Flex does not use terms such as right and left. It uses start and end because And the same exact styling, the same exact values and the start in a different culture, it might be the opposite. So end would be the left as opposed to the right, right? So the browser knows this, so that the browser, depending on the region where the browser is executing, right, it will know that in the US, end is the right-hand side, but if this is in the Middle East, then end might be the left-hand side. Make sense? So that's why those terms are different. Uh, another justify or horizontal justification is space around, and what that does is that the extra white space that is available is equally distributed around each of the elements, right? So for instance, this white space around here is the same white space around here, is the same space around the three boxes. Or you can say in between, where all the extra spaces is divided equally in between, right, the elements. So pushing out the the ends, right, to their extremes, right. So that's justification, horizontal justification. Now, vertical justification, we don't call it justification, we call it alignment. So we justify horizontally, but we align vertically. Okay. So alignment um, can have, again, it could have several values, right? The align items, you could have several values. One of them is flex start, and start, again, in our culture, start is at the top, but in other cultures, start might be at the bottom. Okay, depending on the regional you are, right? So flex start, what it does is that it sticks the content to the top of the container, right? And then the height is no longer calculated by the parent, right? Instead, the height becomes dependent on the content that is inside, right? So notice that now the height is not the same, right? It used to be the same, but flex start changes that to be stuck at the top, right? And then the height is dependent on the internal content. Centers it, so that their center is all the same, nice and even, right? And then there is the end we put at the bottom, right? Uh, One of the more common ways to lay this out is to use the flex basis 100. Right? This is a shortcut, right, that will automatically set all the widths to be the same, right? So they're all evenly spaced out, right? So they're all going to be as wide as they can, and they're all going to be the same. And same thing by height. They're all going to be the same height. This is the kind of like the simplest way to lay out something very quickly, right? To take up the entire width of the screen, right? And it's one of the more common, very quickly, apply flex spaces 100%. Everything's the same, nice and even. Now, once you add this of flex spaces 100, you can start then overriding that one column might be a little bigger than the other, right? That you can apply that says, hey, one is maybe twice the other, or is half the other, right? So that they're proportional to one another. So for instance, here we have a flex applied to this display flex. So three columns, and there's some white space here on the right hand side, right? So we can override, right, the how wide each column is with respect to the other, right? So for instance, we can say if flex grow 1 with 1 means that whatever this means that there's different values, 1, 2, 3, or even decimals. This says take the extra white space, right, and make it all the same across all the elements in the same flex, right? In the flex grow is only being applied to one of them, so it takes all the white spaces, so it grows all the way through, right? If this were applied to several, they would all be the same width, right? So flex grow 1, they will be all the same width, right? And then you can override, maybe one of them has flex grow 2, flex grow 3. It means that it's twice as large as the other two, right? But I'm not going to get into that complication. This one is actually very convenient, in that it allows you to expand or make things grow, right, and take up the remaining width, right? Which is very convenient for laying out our sidebars, right? Where they are very narrow, whereas the main content grows to take up the remainder width, right? So that as we hide or show content, right, the main content is going to take up whatever is left over, right, and it's going to take it for itself, right? So it'll grow that amount of available spacing, right? And then we can make some of the sidebars have a very specific width so that they don't grow, right? That's what we're going to do for our when we implement our Canvas sidebar, our courses sidebar, we're going to give them very specific widths, right? And then the main content where we have our modules and or assignments or quizzes, right? We're going to give them flex grow 1 so that they grow, taking up the remainder of the screen. Okay. All right. Rotating. There's a cool set of exercises if you want to go over that, where you can rotate things. Pretty cool. Individual items or entire tables or entire images. So there's a couple examples if you want to play around with, rotating images, rotating entire tables, or individual rows, which is pretty cool. But I'm not going to go over it. Play around with it if you want. You can also do gradients and fill in some really interesting, um, uh, interesting effects. Okay. All right. Yeah. So then please go over the exercises and um, try to finish the set of exercises by the end of this week, right? Again, just to practice all these skill sets of learning, in particular the sizes, right? Width, height, position, relative, absolute, fixed, so practice that. Make sure you understand those. And also the grid layouts using float or using flex. Go through those exercises. If you want to create, if you're going to go beyond that and you want to play out with other layouts, please do so. Those are very, very important to to understand how they work. And yeah, all right. Okay. Yeah, so let's do office hours. Okay, if you need some help with your assignment, or you have any questions, I'll let's meet up to this. So let's have a really, really short break, and then we'll do office hours. Okay. Right. I'll be right back.